Welcome to today's daily video lesson. Today's topic is trigonometry. As with all daily video lessons, feel free to pause the video and attempt the problem on your own before seeing the solution. Here we have a right triangle. Let's draw a sketch to get an idea of what's going on. We're told that x and y are the two acute angles, so we can label it as such. There's an important identity to be had. If you have a right triangle, then the following equation will be true about the two acute angles. Sine x degrees will be equal to cosine y degrees. And also, cosine of x degrees is the same thing as sine of y degrees. So long as x degrees and y degrees are the acute angles of a right triangle, these equations will always be true. Thus, since we know that x and y are specified as the acute angles of a right triangle specifically, then sine x is going to be equal to cosine y. Thus, cosine y is just 5/13. This principle is illustrated yet again in another problem. We have a right triangle, and we can see that x degrees and y degrees are the acute angles of this right triangle. Thus, sine x is always going to be equal to cosine y degrees. Since we're given that sine x degrees is 5/8, then cosine y degrees will be exactly the same thing. You will need to know some unit circle values. Here we're given an angle, 30 degrees, and we're given a side length, BC, of 5, which is the opposite. We want AC, which is the hypotenuse. The trig function that relates the opposite with the hypotenuse is sine. We know that sine of 30 degrees is going to be the relationship of the opposite over the hypotenuse. Now, from the unit circle, we also happen to know that sine of 30 degrees is equal to 1/2. Thus, the hypotenuse, the side length AC, is going to be 10. Again, the unit circle will come in handy. If we have cosine of x degrees is the square root of 3/2, at this instance, then the sine of x degrees is going to be 1/2. Notice that sine is going to relate to length AB, the opposite of angle x. Since this is the side length we're interested in, we will use the sine relationship instead of the cosine. The ratio is supposed to be 1/2 from length AB to the hypotenuse. That is, the length of AB over the hypotenuse length, which is 8, needs to be 1/2. Thus, we see that the hypotenuse, being 8, causes the opposite side to be 4, to preserve the ratio 4/8 being 1/2. The unit circle sometimes needs a consideration of which quadrant you are in. Usually, in the first quadrant, sine theta being equal to the square root of 3/2 would tell us that our cosine theta is going to just be 1/2. However, we can see that angle theta is being swept into the second quadrant. Thus, when we take in consideration our cosine value, which corresponds to the x coordinate, it is negative. The magnitude is still 1/2, but we simply negate.